This is a problem with the Cascode amplifier and a current source, and they're all MOSFETs. So here's your Cascode, and here is the current mirror. It's just a simple current mirror. The parameters for the MOSFETs are given, and then you need to find R out, which is located here. And the midband gain, which is the same location, VO over VN. So first need to find the current I. So I can be written, because it's a MOSFET, using the ID equation. And VGS is this voltage here. Once I know VGS, I know the drop across it. So it would be 10 minus VGS plus 10 all over 10K is also the current. So you can set those two equal. And then solve for VGS. You'll get two values for VGS. One will be positive and one will be negative. The positive one is going to be the valid one, and in this case the VGS is 4.62 volts. So that's the drop across this transistor and this transistor and this one, so that the current is the same I that is mirrored for each one. So these are all I, which is a value of that we need to figure out. So VGS, plugging it back into either one of these two will determine I. So I is 10 or 20, 10 plus 10 minus 4.62 over 10K. And that gives a value of 1.5 milli for I. Put these equal 1.5 milli. Okay, knowing the current now, the AC parameters RO and GM can be found. So RO is VA over ID. ID is the same for all of them, so 50 over 1.5 milli gives a value of 33.3K. And GM, just knowing ID, can be written as the square root of 2 Km prime W over L ID. And so GM, plug in the parameters here, so 200 micro, 1.5 milli, and that's all the square roots. So GM is 0.7575 milli. And looking at this, I can break this up into two parts. I can look at the bottom one, and then I can look at the top one. Here is a little bit more complicated circuit, so again I can break this up into a simpler one of just these two. So I can lump that all up into one equivalent resistance. So I'll call this R1, and R1 in this configuration, putting on a test source to find the current will give you the voltage over the current, gives you the equivalent resistance. That when that was done previously in class, it was RO 1 plus GM the value here, which is 1K. That ends up being 59.1K. And then if I label this R2, R2 is similar. It's RO 1 plus GM. This time it's now going to be R1. And that is a value of 1.5, about 1.5 meg. So now I have the full equivalent resistance seen on the bottom. The resistance seen up here is solely due to this transistor. And so being a simple current mirror, all I'll see is just RO. So R out is R2 in parallel with RO. And the midband gain AM is just a minus GM R out. And that gives a value of minus 25.3 volts per volt. So R out is 1.5 meg in parallel with 33.3K, so it's approximately 30K. So summarizing these values, R out is approximately 30K. The midband gain AM was a minus approximately 25 volt per volt. And those were the two values that we were looking for.